This is an introduction to linear programming. First of all, we have to answer the question, what is linear programming? Well, linear programming is the process of maximizing or minimizing a linear objective function subject to constraints that are linear inequalities. So what does this really mean? Well, we might have a situation where an employer would like to maximize profits. This profit function would have to be a linear objective function, and then it would have some constraints involved with it. Something that might be like wages, product costs, or utility costs, and these would be linear inequalities. So what we're going to do is try to find a way to find maximums or minimums of this linear function. Here is just an example of what it might look like. If we were asked to find the maximum and minimum values of this linear function, and then it's going to be subject to the following constraints. These are the constraints that this linear function has to work within. The first step that we would want to do is to take these constraints and we want to graph them on a coordinate graph. So our best thing is to put them into a graphing process, so probably a slope-intercept form. So here we have that set of constraints, and now what we've done is put them into slope-intercept form. So all we've done is done some algebraic manipulations, like x plus 2y is less than or equal to 14. What we want to do then is solve this into our slope-intercept form. So we're going to subtract x from both sides. We're going to get 2y is less than or equal to negative x plus 14, and then divide by every single term by 2, and we get y is less than or equal to negative 1/2 x plus 7. So that is just changing the form from standard form to slope-intercept of each one of these inequalities. The next step now is to actually graph these set of constraints onto a coordinate graph. So in red here you see the three constraints that are in our slope-intercept form of our inequalities, and what we've done now is graphed those three constraints onto our coordinate graph, and the next step now is that the maximum or minimums occur at the three vertice points. A vertice point are where two lines intersect. So in this case, our graph has three vertice points, and now what we need to do is to determine what the coordinates of those vertice points are. So we have just graphed the systems. We found three vertice points. Now what we're going to do is actually find the coordinates of those vertice points, because we know that the maximum or minimum has to occur at these vertice or corner points. So what we're going to do is take the system of equations, the two lines, and solve that system to find that point of intersection. So here's our first system of equations. We're going to use substitution in order to solve this. So we set negative 1/2 x plus 7 equal to 3x, substituting for the y's, and you end up with x equals 2. You substitute it back in and find y is 6. So this is our first corner or vertice point. We take the next set of equations and we solve it by substitution, and we find that the second vertice or corner point is at 6, 4. And then we solve that third system and we find out that that corner point or vertice is at negative 1, negative 3. This might be a great opportunity to stop the video and go back and look at your graph and confirm that these are your three vertice points. One of the last steps here is to take those 3 vertice points and plug it in to that linear equation and find out the values for these vertice points. So what you can see is I've circled here the objective quantity, which was z equals 3x plus 4y. That's what we're trying to find the minimum or maximum values to. Then I'm going to plug in my first vertice point and evaluate, and I get an output of 30. Then I plug in 6, 4 into this equation and get an output of 34. Then I'm going to plug in -1, -3 into the equation, and I get an output of -15. So the maximum is going to occur at 34 at the point 6, 4, and the minimum, which is -15, occurs at the point -1, -3. So we have solved this linear programming problem by finding the maximum and the minimum of this objective equation. That is what linear programming is all about.